In this DeBacco University video, I'm going to be going over writing ionic formulas, which will ultimately look like this. If you want to get into the naming of those formulas, there'll be a separate video you can find on this channel. All right, let's go through the steps in writing ionic formulas. Well, the first step is you want to identify the ions. Determine the cation, which as a reminder is the positive ion, and the anion, which is the negative ion. So if we're looking here at sodium chloride, Na plus would be the positive cation, chloride would be the negative or anion. We're going to put those together in our formulas. Magnesium here, or polyatomic hydroxide here would be another anion, and this is what we're going to be working with as we go through and make our formulas. Then you want to determine the charge. So you're going to use the periodic table or an ion chart to find the typical charges. So calcium typically has a +2 charge. If you look at the family on the periodic table, nitrate is a polyatomic ion that we would find from a table, and providing you with that would have a -1 charge. So here we've got sodium, and we've got oxygen as another example. Take the 2 from the oxygen and use it as the subscript for the sodium. Then take the 1 from the sodium and use it as the subscript for the oxygen. Note subscripts of 1 are not written, so this formula would become Na2O. So we can see we're taking those charges, we're using basically what's called the crisscross method, or simply crisscrossing them. However, just as a reminder, we don't write the 1 there. We do carry the 2. We just carry the numbers, none of these signs that go with that. So for lithium and oxygen, applying that same concept right over here. The 1 goes over here, and the 2 goes over here, Li2O. Now keep in mind when I say subscript, that 2 is down below where you write the letters there. Then you simply want to balance the charges. So total positive charge must balance the negative charge. You may need multiple ions to achieve this balance. So here we can see in this other example of aluminum sulfate, we've got aluminum having a +3 charge, the sulfate SO₄ having a -2 charge. We cross them here, that 2 goes there and that 3 would go there. Now we put those parentheses because we don't just want it to be over the oxygen, we want that to be over the entire polyatomic ion of sulfate. Another example here, barium nitrate and ammonium phosphate. So here we could see, taking those parentheses become very important, particularly when we're looking at multiples of those polyatomic ions. Then we simply write the formula. So we start with the cation, and then that would be followed by the anion. Use subscripts to show how many ions are needed. Don't just show the changes in the final formula, just the correct ratio. We see many examples here of calcium and nitrate, aluminum and hydroxide, barium and sulfate, and so on and so forth. Here, when we cross those, sometimes we have to go through and reduce the subscripts. Sometimes we have to use parentheses, but we only use those parentheses when we have multiple of a polyatomic ion. In the examples here, we do not need to go through and write those polyatomic ions there. As we don't need to put parentheses, I should say, around those polyatomic ions, simply because it's assumed that there is one. And we can't reduce this anymore, so therefore, we just leave it as is. In this case, where we can have a reduction because we're looking simply at balancing the charge, we would do so, and that would be, quote, our final answer. So just some general tips here for transition metals. They might have multiple charges, and then Roman numerals can help, particularly when we get to the naming compounds. For polyatomic ions, they should be kept in parentheses if you need more than one, as I tried to show you in those other examples. Again, because that 3 is going to be then distributed to the entire molecule. If you didn't have that parentheses, it would just be distributed to that 4 of that oxygen. So just keep those in mind. Keep track of your cations and anions. Keep track of your charges. Make sure everything balances out in the end, and hopefully you'll find writing formulas for ionic compounds fairly easy.